Okay. So these are the reasons for failure, schedule slippage. So we can track when design should complete, then testing should complete, when should be the alpha testing should be released. So like that. When you say product, not just coding, okay, coding is one portion of the project. It also includes even user manual also, isn't it? Even if you buy a small modem, one page write-up will be available there, isn't it? How to switch on, where is the LED, it can be for fridge or anything. So similarly, anything we do, a write-up is required for that. Overall, like that, I'm telling you, as a total. So schedule slippage, cost overruns, and do not solve user problem like that. So every aspect of the project development should be taken care. See, no control or review, technical incompleteness of the developer, poor understanding the cost and effort by both the developer and user. So these are a couple of problems, reasons where a project is likely to fail. So we understood about this project and large project. Now we're talking about software process. It is there in your syllabus. The process is the structured set of activities required to develop a system, which includes specification, design, validation, evaluation. So initially we saw 15 steps. That altogether is called software process. Okay, all SRS, testing, designing, reviews, training, deployment, all these things are steps towards the software process. The roadmap to build high quality software product is a software process, in the sense, if you want to develop Lotus project with very high quality, then you have to follow the software process. Process means, which I explained in the very beginning, the 15 steps as applicable to the project, of course. The software processes are adapted to meet the needs of software engineers and managed as they undertake the development of the software product. A software process provides framework for managing the activity that can be easily get out of control. Or can means if something can go out of your control, there will be a framework for the project development that will be monitored and addressed initially. Different projects require different software processes. That is what I told, though I have listed all the process involved in a project development, and it goes with the project. Whatever is applicable can be adhered to the respective project development. The software engineers work products means program work. See, work product means programs, documents, data. All these things are work product. Document can be test document, review document, design document, SRS. Okay, that kind of thing. The software engineers work products are produced as consequence of activities defined by the software process. See, you will take up respective activity based on the software process. The best indicator of how well a software process has worked are the quality, timeline, long-term viability of the resulting software product. I don't know. Quality means I developed a software Lotus. 10 times I can use, 11th times I'm not sure whether it can work or not. That way, timeliness. It should be done as it's supposed to work. You log into IRTC website, or you will log into any bank. If it is authenticating you after 1 minute, what will you do? Assume you logged into ICICI Bank and it authorized you or identified you after 1 minute. What will you do, Amol? Omkar? Monalisa? Nobody is there? Ankit?
Yes, ma'am.
What will you do? For timeliness, I'm talking. Say you developed a product, okay? Or let us take ICICI Bank login. You want to log in and check your balance, or you want to transfer money to somebody, but the login process is so much and you logged in, gave a lot of input. After 1 minute, it will identify and allows you to come in. What will you do? I'm asking.
I won't use it further.
Next moment, you will be in SBI or Axis Bank. You all have no patience. You click, it should work. For that, whatever backend developer should do, he should do it, right? He can do design however he wants, but it should happen within, say, 5-second login mechanism, correct? So that's what timeliness and long-term viability, and you should develop such a way that you develop it today, tomorrow that sensor is out of order. It should not be like that. When you use this in pure software, no problem. Whenever is a firmware involved, you have to take care of developing tools or compilers, etc. So whatever you should have, the engineer should have a vision, not long-term vision. So that should be taken care well in advance. So if you sit and develop some app exclusive for Windows 7 or Windows 8, what can you say, right? Well, some more definition. Yeah, so software process, little more about this. Now, I just want to tell about this portion here. Nevertheless, you all should read, and anything you are not very clear about any of these things, you can always ask me either afternoon or tomorrow morning, okay? Or last day. Any day you can ask, madam, this PPT, I didn't understand. What is that? Can you elaborate with a use case? Like that, you can ask, okay? See, generic software Engineering phases means definition phase, development phase, support phase. See, initially we saw 16 steps, isn't it? That is nothing but this more elaborated. In that also, out of 15, certain things will go into definition phase, some more go to development phase, some will be in a support phase. So altogether, that's what I told before starting my session. It can happen, like each practitioner may see in a different way, but in essence, all are correct. If somebody asks you what are the software processes steps or something, then you can tell definition phase, development phase, support phase, definition phase includes this, development phase includes this, like that you can talk, or I can tell straight away the steps. It is okay. Now we'll go back to more. See, definition phase focuses on what? Okay, that means information gathering, project planning, requirement analysis. Development phase focuses on how, means design, code generation, software testing. Support phase focuses on change, correctiveness, maintenance, adaptiveness, etc. See, process characteristics. Why we adhere means mainly to understand whatever we are doing, are we understandable by all? Visibility, the process progress is externally visible. Supportability, supported by various tools. Just now I told you are using microcontroller, something which where compiler is not available. What is the use? If it is IoT project, you are using something which is not available right now, that sensor. So that kind of thing. Acceptability, is the process acceptable? Those involved in it. We are developing, we should involve Lotus team, that hospital team on and off to make sure we are in track, right? They may say, oh, okay, this I gave, but it is wrong. It should not be like this. It should be like this. That's perfect, no problem. Because otherwise, anyway, we have to do as per the clients, the doctors. Why? And after 4 years or after 6 months at the end of the project, you have to involve them wherever possible in the beginning, so that now things will be, so the project can be developed with quality, with the same cost at right time. What did I say? Project can be involved clients or stakeholders at appropriate stages or all the appropriate stages. So the project can be developed at with the required quality at right time with the same cost, proposed cost. Okay. Reliability, are the process errors discovered before the result in product errors? So we have to check the proper checking to be done. Then robustness, can process continue in spite of unexpected problems? This is the robustness. Engineers can take about if you're a domain expert, you can visualize the unexpected scenarios in the domain, and you definitely can take care of that. In the sense, you are designing this earlier Snapdeal one project, software service was there. Ugadi day, Diwali and New Year, they open the offer. It will, after 1 lakh login or something, it will crash. That should not happen. Our design should be such a way that it should not crash anytime. But still, that is okay, fine. But initially, during the understandability, we ask how many simultaneous logins are there, will be there. If it is a web-based application, something like that, Snapdeal or Amazon. So they will tell, we want the simultaneous logins are expected, say 1 lakh. Simultaneous logins. All, see, I may log in, 2 lakhs may be using the app. That's a different issue. Simultaneous login. So that we design for that requirement. As an engineer, we may keep buffer. We may keep 20% extra at sustainability. So that kind of thing. Then maintainability can be the person meeting the changing the organization leader. You can't say my software works only on Windows 8.1. It doesn't work on 10 or 8.2. That's not the way. Okay, rapidity, how fast a system can be produced. So all these things are a process characteristics. This now is a specification, design, manufacturing, testing, installment, and these are all the process models. Leave it, that you can understand. Inherent problem with the software development. Okay, now a little more. We saw something. Why it fails. Okay, that's all we saw. See, they are interlinked, but they are not same. It appears same, no, but they are not same. When you read many times, you will understand. And better read. Inherent problems with software development. See, we'll go. What are the stages? See, requirements are complex. The client does not know the functional requirements in advance. So let us take our Lotus example. Let us think CDAC and hospital A is sitting together, and they are telling we are capturing. If see, they tell in English, we convert into SRS. That's perfectly possible, provided if they tell all the requirement. If they don't tell properly, then we may develop for Linux platform also, which they never ever use Linux platform that way. Or they may say something, if they're not told multimedia, then we may not develop the tutorials or a lesson for respective children's in audio and video based, right? So that kind of thing. Requirements may be changing. Obviously, requirements will change, but whatever they say, technology enables, introduce a new possibilities to deal with the non-functional requirement. See, there are so many functional, little more later I think, in SRS, there will be functional requirement, non-functional requirement. Here they're trying to tell non-functional requirements are likely to come across, not only non-functional, any requirement change might come. It's our engineer's duty to see how to accommodate those changes. Next, third one, frequent changes are difficult to manage. Identifying milestone and cost estimation is difficult. When there's a frequent changes, what happens is milestones we cannot fix. Means we can't tell 4th I'll release this, 25th I'll ready for alpha release, like that. No, we find it those are the milestones, okay, and very difficult. And obviously, cost is directly involved in many things. It means every phase. There's more than one software systems. New system must be backward compatible with the existing system. This is about when you develop a phased development. Need to distinguish between the system under the development and already released. So these two things be taken care. Last, let us view this problem as a non-functional requirement for a system that supports software development. Okay, here this leads us to the software lifecycle modeling. In order to address all these things, we have to adhere to the software development lifecycle model. See, that's what initially we saw. Software is not manufactured or engineered. It evolves like that. Okay. Now, if the software is usable, it will have changes in it and have a feature release that way. Now, clients will add new feature or a user's wants to changes. In either case, software will be evolved. We are ready to take up the software, any new changes or new features based on the complexity of the requirement, whatever is supposed to be done based on the cost and other approval factors. They say if you have a, this now we saw, no, you have a program or a project and some changes to be done, well, then and we don't have a practice of following any of the software development standards, then very difficult to manage later. That is what they're telling. So what are the software means? This is a software development lifecycle. Here you can see all projects which we develop should adhere to software development lifecycle models, which we told software process, both are same. Okay, here no, they are telling requirement analysis, design, implementation, testing, evolution. So as far as the red is the starting point, rest all will follow. This only in broadly I have explained in the interview. If they ask what are the software development lifecycle steps, can you define software development cycle? Anything you can tell these 5 steps, including training, testing, releasing, post-mortem analysis, everything can be told. So project lifecycle, initially we saw no, that one. The various phases which are undertaken sequentially when development of the various phases which are undertaken sequentially when developing a software are commonly termed as SPLC. And in previous slide you saw 5 categories broadly done, or you can even tell all the 15 types if you can remember. But okay, no need to take much time to answer this. The software development lifecycle begins with the identification of the requirement for a software and ends with the formal validation of the developers. You should know that which is the beginning and ending, but many things can start simultaneously. Okay, this another way of telling software lifecycle. They say conception, childhood, adulthood, retirement. Okay, pre-development, development, post-development. I have recorded here. Okay, now as per IEEE standard 1074, standard for software lifecycle is IEEE standard 1074. Project management, pre-development, development, post-development, cross-development. So in this, here you can see whatever we defined the 15 steps grouped under various things, installation, requirement, and this you can match and mix and match. And so you can also tell these few steps, or even you can tell the subsequent steps. In either case, that's why in the second, initially I have listed all the project development steps. Okay, here is some various phases of. See here only see where this slide, IEEE standard, and this. There's outside you feel when you see the English you feel a lot of there's no matching, but when you see the software engineering, yes, they are same, more or less same, the same. Okay. So here feasibility, analysis, assessment, planning and estimation, system requirement specification, system analysis and design, coding, testing and validation, release, delivery, deployment, maintenance and technical. All these things are 8 steps are given here. Okay. And here it is shown all the 8 in 5 steps. Here it is another practice where it is showing they define the conception, childhood, all the same 8 steps are done here. It's like that. So I don't want you people to get confused what is what. No, it's not that where what is happening. Don't worry. All you have to know, there are various practitioners might call like that, but in essence, when you develop, you have to do all those 15 steps, whatever with the grouping. Now each one is explained. I may not explain here. Only one I'll tell the flow. System study of a user requirement to know the hurdles before doing the system. Generally, following areas are analyzed in the phases: technical feasibility, project schedule and time frames, financial activity. See, when you see project, finance also very important for us. And also they try to tell for the respective particular activity who are the key players, analysts, developers, and testers. Well, next, deliverables. What is the outcome of this activity? Feasibility analysis report will be generated. Similarly, planning and estimation also, who all are involved? They've explained about the activity. And players means the members, key team leaders, and senior developers. The planning and estimation, the very fresh are not required. Why tester means they do the test cases, test planning they do, further it is put. Okay, then deliverable estimation report. SRS and use cases can be delivered here. Because anyway, SRS we are reading a little more after. System analysis and design. So here also, who is there? Architects and developer. What are the deliverables? High level design, architectural diagram, test plan, test scenes, like that. What is it? All these things are part of system analysis and design. Then comes coding and unit testing. Same developer only to see. Here you can see, here managers, business analysts. So we cannot put. We have put only the developers. Next, deliverables, unit test report, and beta version of application. Automatically just okay. After testing or coding, what will you do? Test report or a review report, right? Then more testing. See, this is coding and unit testing. Okay, here testing. Okay, after the coding is done, the testing will be taken out. So what are the C? Validating the system against the user requirement, right? See, validating the system against the user. You are testing. What are you testing? We're testing now in this, as per this English, we're testing Lotus project as per the user requirements. During the testing, the application is tested against the requirements to make sure that the system is actually meeting the needs of the users addressed in the requirements space. So while doing that, we take the SRS. Doing this testing, what we do? We take up the SRS testing. We make sure the product is working as recorded in the SRS. Test engineer and the test leads, who write the test plans and test cases, they do. What is the deliverable of this case? Right, the final version of the complete application after testing, the final version of the software will be released. Test summary report, incident report. See, we do testing sometime when there is any breach, security breach, or some incident happens. So that also we should tell, okay, because of this condition, in this indication, because of this condition, this indication has come, that kind of thing. And test status report, progress and status of testing. That's intermittent. Some bug is reported, it's not yet fixed. So that time intermittent test report is called test status report. Any questions so far? Well, after all the development, testing, etc., delivery, release, and deployment. See, if it is a software of the product, then we just deliver to the market. If it is a release, then it is a software as a service. So deployment, if it is the same thing, or sometimes it is a solution, by other clients, then we go there, deploy, and make this environment check and come. So that is why release the application to the end user environment for real-time use that way. So here the key players would be developer, test engineers, and team leads. Last, maintenance and technical support also. Here also, you can decide whether you support 24/7 or only 6/7, whatever it is. That is our project. We will decide the support system. So with this, as I told, I have completed Introduction to Software Engineering, Software Development Lifecycle,